Hello, we're going to make a video, and um, oop, this video will demonstrate how to do the following things on SHA-03. Uh, we're going to show how to initialize the base Anaconda Python environment. We're going to create a virtual Python environment, use the new virtual Python environment, use some Python commands to confirm that Python can see the GPU. We're going to install more Python packages into our virtual environment to allow some Python scripts to run. We're going to copy some sample Python scripts to our user ID, and we're going to run some sample Python scripts and monitor the GPU. Okay. So I've brought up a couple of, I've logged into my ECE demo ID, and I'm running something called tmux, so I can have multiple sessions going at the same time, and we'll probably zero in on the session that's applicable in the video, so it'll be a little bit easier to read. So I did an ls up here in the top left hand screen, and you see the directories I have. Now I'm going to first thing I'm going to do is I'm going to need to source an environment script file to put us into the base environment for Anaconda Python. And and this has been done on some previous videos. For those of you that may have seen the previous videos, I'm going to do this more quickly with less explanation. So I'm going to get a command here. Now what I'm going to do is I'm going to run a symbolic link command, and this symbolic link command will create a file. You can now see a file that's in kind of a lighter blue, that or cyan, I think they call it, that is a symbolic link to. All right, let me do this. So it's a symbolic link to this other file on the machine. That is the environment script file. This will save you some keystrokes so you don't have to type out that entire path. So what we're going to do here is we're going to source. Now you don't have to run this symbolic link command each time you log in. That's a one-time thing. I just happen to have removed it in between videos. If you saw the other video and you saw me do it and you see me do it now, the only reason I'm doing that is so it can be done on this video for demonstration. Okay, so I'm going to source that. And you can tell I'm now in the base environment because you can see the word base on the left-hand side of the command line. And so what we'll do is we'll type conda env list. This will show us all the conda environments we have, and the only one we have right now is our current base environment. So we're going to want to be able to run TensorFlow GPU, and if I run the conda list command and I pipe that to the grep command and I look for the word tensor, that's going to come back, it's not there. So we're going to run a command to create a virtual environment, and we're going to put the TensorFlow GPU in that new virtual environment. Okay, so this is the command that will create the virtual environment. You can see it says conda create and then -- name, and then that's the name of the virtual environment. That name can be anything you want. I just called it my GPU env. And then I'm going to put Python into the virtual environment along with the various packages that are listed afterwards. I'll go ahead and hit enter. And this is actually pretty quick, making this virtual environment. And we can wait while we're doing this here. Yet the Python system management is a very complicated thing, and this package called Anaconda is a Python package management system, and it makes life a lot easier. And what we're doing here would be very, very difficult using the regular distro packages. Okay, so that's all done. As you can see, it has some commands in there on how you get into your virtual environment. First thing we're going to do, though, is we're going to type conda env list. And now you see that there's two virtual environments. And you notice there's an asterisk next to one of those virtual environments, and that just happens to mean that that's the virtual environment that is currently active on this bash session. So what we're going to do now is we're going to type conda activate my GPU env, and you can see on the left hand side it says my GPU env, and that tells you that I'm now in that environment. And now if I type conda list env list, okay, you see it lists the two virtual environments, and you can see on this bash session I'm actually excuse me, the active session is the one with the asterisk, and it's the my GPU env. Okay, now I want to run some Python commands. So what I'll do is I'll type Python, and this will put me into Python. And I want to import TensorFlow as TF. And then I'm going to run a command to see if the Python environment can see the GPU. And so this is TF test. Is there a GPU available? And so the end result is true. There is a GPU available, and it will put up a lot of information here that you can see, and so that worked. That's good. And there's another command that we can run. It's similar, but it will just also check to see if that GPU is available. This will list the physical devices, and then you can see here that there's a GPU available. Okay. So we're going to quit out of that. And so we quit out of the Python. And actually, I'm going to go back into that. So I want to install a few packages. I have some scripts I'd like to run just for illustrative purposes, Python scripts. And I need a few packages, additional packages that I didn't install on the original installation of the virtual environment. So the way that you can install packages, and generally what I'll do is I'll Google conda PyTorch, and it will give me the information I need to install PyTorch. So to install PyTorch, I will need to say conda install PyTorch, and then there's a PyTorch library, and then I say -c PyTorch, and it will use that repository to get to PyTorch. And the PyTorch CUDA, I think the library is the NVIDIA library. Okay, so we're going to go ahead and run this and install this into our virtual environment. And it found everything, and it's asking if we should proceed, and I'll hit yes. And again, this shouldn't take too long to install. And then we're going to copy over some Python scripts that we'd like to run and put them in our user home directory. Okay, it's all done installing the new packages that I was looking for to use. And so in order to copy, and you can copy these packages if you want to try and duplicate what I'm doing, you can copy these packages too. So first thing I'm going to do is I'm going to type cd just to make sure I'm in my home directory root. I'll type pwd, and that shows I'm in the home directory root for ECE demo. Okay. And then I'm going to actually paste the command in. Okay, and you may want to stop the video and get this command. I'll try and remember to copy some of the commands that I'm using into the description, and you can copy and paste from there. Okay, so I'm going to run this. This is going to copy. I see a mistake I have. That should be -r, since this will be a directory that we're copying. Okay, and so here I'll type ls, and now you see a directory called Python GPU test scripts. So I'm going to do a change directory into Python GPU test scripts, and I'll do an ls. And the basic difference between these two scripts is one number's been increased. So if I go to PyTorch multiplications, so what you can see here is this will go ahead and run, and the number of iterations is set at 1,000 on this file, and on this file the number of iterations is set to 1 million. Okay, and if I type Python PyTorch matrix multiplications.py, it tells you the GPU it's running on, and it gives you some output. Okay. Now, before we run the one that's going to run for a while, what we're going to do is we're going to come down here to the second screen, and we're going to run a program called GNOME System Monitor. And while we're waiting, this is a graphical program. Okay, and this basically is going to show us what is happening on the CPUs, not the GPUs on the card. We're going to make this a little smaller. Okay. So this will show us GPU activity, and we'll see what's happening. If we take a look here, it shows how much each CPU is being utilized, and uh, the utilization right now is pretty low. Nobody's running anything on this. Okay, so the other thing that might be interesting to do, so what we're going to do here, actually, we're going to run something called htop. So we shouldn't lose that. Okay, this will do the same thing. This will show the CPUs um, and what's happening in terms of um, the gigabytes of memory and that's being used. Okay, and actually let's so now we're going to run the Python script. That's the smaller Python script, and it will run pretty quickly. Okay, and I'm not sure how useful this will be. Okay, so what we're going to do now is we're going to run a command. Before we run this command, there's a NVIDIA SMI, NVIDIA System Management command, and in order to know what the parameters are for this command, you can run this NVIDIA SMI and then help query GPU. And if you do that, this will give you a listing of the various parameters and what they mean. And so the command we're going to run for this is going to be this NVIDIA SMI command, and we're going to run this so we can monitor what's going on. And we're going to tell it to take a snapshot. So I'll put -L 2. So this will take a snapshot every 2 seconds. We're actually going to save this to a file. And we'll do that by piping this to the T command. And we'll call this long running GPU info.dat. Okay, so and good enough. So so what we're going to do now is we'll go ahead and run this command. And this is going to take a snapshot every 2 seconds of what's happening on the GPU. And what it does is it gives you a timestamp, the GPU name. This is the temperature, and this is the amount of utilization. Next thing is the total amount of memory, and then the amount of memory used. The next thing is the wattage being drawn, and the very last thing is 125 watts is the maximum wattage that this GPU card will draw. Okay, and we'll come back in here to this screen with our programs. our Python scripts, and we're going to run Python PyTorch matrix multiplications, and we're going to increase the runtime, and we're going to hit enter. And let's see what happens. And as we're monitoring this, we can see over here that the utilization has gone up to 100%. The temperature has gone up to 53, 54, 56 Celsius, 7, and it's increasing. The amount of memory, this is the total amount of memory is 8 gigs. Right now we're using about half a gig of memory. The amount of wattage being drawn on this card right now is up about 122 watts. Now it's 123. So the wattage is being very heavily drawn. It's drawing about the maximum amount of wattage that the card can handle. Now over here, looking at the htop command showing the actual CPUs, it doesn't look like there's a lot of difference in the CPUs. And let's see if we can get this guy here. So yeah, we're looking at the CPUs. The CPU usage hasn't really jumped up much. Now that network usage, part of that's from me dragging the screen around. If I drag this screen around, I expect that network usage may jump up. And again, we're consistently using that card at 100%. The temperature's up around 79 degrees Celsius. And we're still drawing about 120 watts of power. So, okay, so that's one way you can monitor what's going on. So what we're going to do now, I'm going to go ahead and kill this job. Okay, so I interrupted that job, and the utilization went down to 0. Temperature's starting to drop on the CPU card since I killed that job. And you can see the wattage dropping that it's drawing. A big drop from when the job was running and killed, and now it's dropping down. Okay, so that's an example of how you can run a Python script. You can actually monitor what's going on. We're going to actually come over and stop the NVIDIA SMI with a Control C here, and we stop that. Now what we'll do is we'll type ls, look at our files, and we've got that file in there called longrun GPU info.dat. Again, if I was going to look at that, I'd use the vi command. Again, there's a bit of a learning curve with the vi command, but this would enable me to go through and take a look here pretty quickly at what was going on. This file can be loaded into a database if for some reason you want to do that, because it's a common separated file. The delimiter is a comma. It might be easier for somebody not familiar with VI or Emacs to use gedit. We'll give this a second to come back. Okay, so this is basically like a notepad editor, and you can I'm using my mouse to scroll through it. But this shows the results that were being displayed on the screen with the NVIDIA SMI command. Okay. So this is a very quick introduction into running Python and monitoring your GPU. And that's all I have for this video. I hope it was helpful, and thanks for listening.